Hi, ladies and gentlemen. We are looking at page 2 of our notes, notes 5.1, which are on angle relationships in triangles and quadrilaterals. So let's remind ourselves of what we discovered in class. So the first thing we're going to look at are sums of exterior angles of a triangle. And hopefully you remember that the exterior angles of a triangle will add up, of any polygon, will always add up to 360. But we're going to verify this to make sure that it's really true. So for starters, I'm going to use an online geometry software, and I'm going to do a quick exploration to make sure that our conclusion is correct. So I'm going to create a triangle, just a totally random triangle. Doesn't matter what type of triangle it is. And I'm going to extend each angle so that I have exterior angles. Excuse me, I'm going to extend each segment so I have exterior angles. So if you notice right here, we have 3 exterior angles, and I'm going to measure how big these angles are, okay? When I measure these angles, I want to see what I will end up getting. So I'm going to measure them, and then I'm going to bring you back to the screen so you can see what we get as our measurements, okay? So if you notice right here, angle ABC is about 137 degrees. Angle FDB, this angle right here, this exterior angle is about 100 degrees, and angle DCE out here is about 123 degrees. So I'm going to add up these angles and see what I end up getting. So I'm going to add 137 plus 123 plus 100, and I get 360 right here. So what I'm going to do now is I'm going to actually create an expression where I can calculate what the sum of all of my angles are going to be. So I'm going to take this first angle, I'm going to add the second angle, and then I'm going to add the third exterior angle, and it tells me that the answer is 360 degrees. Okay, so now what I'm going to do is I'm just going to hide this for a second, but I just wanted you guys to see that that was 360 degrees. And I'm going to play around with my triangle right here. So if you notice right here, as I move my triangle, my angle measurements are changing as well. Okay, so when I change my angle measurements, the question is, what happens to my exterior angles? Well, let's see. So here is the sum of all of my exterior angles, and when I change my angle measurement, notice how this sum keeps constant. It's consistently 360 degrees. So therefore, I can definitely conclude that the sum of the exterior angles is going to be 360 degrees. So we're going to say right here, the sum of the exterior angles of a triangle, 360 degrees. Okay? All right, now the exterior angle theorem, we're going to explore that right now too to see what we end up getting. All right, so now for the exterior angle theorem, I created a triangle and I measured the 2 interior angles right here, and then its exterior angle that does not touch these 2 interior angles. And if you notice, this interior angle is about 43, and this one's about 79. And if you remember, we added the 43 and the 79 together, and we got about 122, which is pretty much what we have right here. But I'm going to calculate this value. So I'm going to actually add this angle plus this other interior angle, and I get the exact same value that I have for my exterior angle out here. And if you notice right here, if I move this, even though the angle is changing, the actual sum of the angle right here, this value, is always going to be consistent with this value, no matter what happens right here when I change where my angles are going to be. Okay, it will always, these 2 interior angles will always add up to the exterior angle right here. So let's go ahead and draw a picture of this so we understand what's happening. So it says the sum of the 2 remote interior angles. What does it mean for it to be a remote interior angle? It means that it does not touch the exterior angles. So right here, our remote interior angles are angles A and B, and then the exterior angle is angle C. And remember, we have multiple exterior angles, but this one's the one that's on the outside that doesn't touch A and B. So we can say that angle A plus angle B is going to be equal to angle C. And so we're good for the exterior angle theorem, okay? if you notice, we have our quadrilateral right here, and I measured all 3 angles inside of my quadrilateral, and I want to see what happens when I add up all my angles. So right here we should get, this is about 71 degrees over here. This is about 148. This angle up here is about 81. And this angle over here is about 61. And because of my rounding, I got a little bit off, but I got about 360 degrees. But if I actually measure it, if I actually calculate it with all the decimals and no rounding and all that kind of good stuff, let's see what we end up getting. We end up getting exactly 360 degrees. And no matter where I put each one of my vertices, my angle measurements are changing. However, the sum will always be 360 degrees. So we can go ahead and say that the sum of the interior angles of a quadrilateral is 360 degrees. Inside of it is 360 degrees. And if you remember, when we did our exploration, when we have a quadrilateral, we get 2 triangles inside of here. So it's really essentially 180 times 2, which is equal to the 360 that we're looking for. Okay? And now we'll look at the sum of exterior angles. Now I want to take a look at the exterior angles that I have here. So I have my exterior angles. I have them highlighted here. If you notice, these are my exterior angles, and I want to see what those are going to add up to. So I'm going to take about 32 degrees. I'm going to add about 109 degrees for this angle right here. This angle here tells me to add about 119 degrees. And then lastly, right here, I'm going to add about 100 degrees, so I get 36 degrees. But let's actually measure or calculate the measurement of these 4 exterior angles. So I'm going to take the first exterior angle, add the second one to it, the third one to it, and the last one to it. And we will end up getting 360 degrees again. So now when I change the location of my points in my quadrilateral, I still end up getting 360 degrees is the sum of my exterior angles. So I can go ahead and say that the sum of the exterior angles is also 360 degrees. And if you remember when we had polygons, the sum of the exterior angles of any polygon will always be 360 degrees. Okay, so now let's look at some practice problems. Number 1A. If you look right here, these are our remote interior angles, and it's asking me to figure out this exterior angle. So we'll call this exterior angle right here x. So we know that the relationship is that 80 plus 45 is equal to x, because we know that if we add the 2 remote interior angles, it will equal the exterior angle. So I end up getting 125 equals x, and I'm done with this question. Okay? Now, in this problem right here, I know one interior angle, but I don't know the other interior angle, so I'm going to call this other interior angle x, and I know that the exterior angle is 60. So this time my equation is going to look a little bit different. It's going to say x plus 16 is equal to 60. So I have to subtract 16 from both sides to get what x is. So therefore x is 54 degrees. Okay? And sorry about this, don't forget your degree measurement. Hopefully that makes sense for our exterior angles. So then in number 2, it says solve for x and then find the missing angles. So this time I know a remote interior angle here is 50 degrees. I also know another remote interior angle is 7x plus 1. And I know that if I add those together, it should equal my exterior angle over here, which is 13x plus 9. Okay? So if I were to write this out as an equation, I can say 50 plus 7x plus 1 is going to equal 13x plus 9. And now it's just a basic equation to solve. I've got 50 and 1, so I put them together, so I get 7x plus 51 is equal to 13x plus 9. Okay? Subtract the 7x from both sides. This is just a review of solving equations. So I get 51 equals 6x plus 9. Subtract the 9 from both sides, and I end up getting 42 is equal to 6x. Lastly, just divide by 6, so I get x equals 7. Well, now that I know that x is 7 right here, I can use that information to figure out how big each angle is. So the first angle that I need to figure out is angle R right here. So I'm going to say right here, the measurement of angle R, and it's really important that you say the measurement right here because we're talking about how big it is. And we know that in terms of x, it's 7x plus 1. Well, we also know that x is 7. So I'm going to do 7 times 7 plus 1. So I'm going to say 49 plus 1. So I should end up getting 50. So I know that the measure of angle R should equal 50, okay? I also need to figure out this outside angle right here. So I can't call this angle P because if I call it angle P, I don't know if I'm talking about this angle or this angle right here. So I have to call it by 3 letters. So it's going to be called angle QPN. So I'm going to find the measure of angle QPN by writing out the expression. The expression says 13x plus 9 right here. So I'm going to get 13, and I know that x is 7, so I'm going to replace it with a 7. So it's 13 times 7 plus 9, okay? And then when I do the multiplication here, sorry, let's be consistent with our colors, plus 9. When I do my multiplication here, I end up getting 91 plus 9. So therefore, I can say that the measure of angle QPN is equal to 100 degrees. And that should work for me because if this angle right here is 50 and this is also 50, then this angle out here should be 100, and then I'm good to go for this question. Okay, a couple more questions and then we will be done. All right, number 3, if the ratio of the exterior angles of a triangle are 3 to 4 to 5, find the measure of the angles. So I'm going to draw a picture of what's happening. So here's my triangle right here, and I have exterior angles. So I'm going to extend my angles right here so I can see what kind of angles we have. And it says that they're in a ratio of 3 to 4 to 5, which means that one angle will be 3x because we know it's a ratio of 3 to 4 to 5, but we don't know 3 times what, 4 times what, 5 times what. So we can just call it 3x, which means that this one would have to be 4x, which means this one would have to be 5x. And I know if I add 3x, 4x, and 5x together, the exterior angles will always add up to 360. So I can just say is equal to 360 right here. So right here, all I have to say is 3x plus 4x is 7x plus 5x is 12x. So I get 12x equals 360. Divide everything by 12, so I get x equals 30 degrees. So that means that my first angle is 3x. So I can just say 3 times 30. So my first angle should be 90 degrees. Okay, my next one is 4x, so I would get 4 times 30, and that should end up giving me 120 degrees. And then my last angle is 5x, so I would say 5x equals 5 times 30. When I multiply 5 times 30, I get 150 degrees. So therefore, my 3 exterior angles are 90, 120, and 150. But let's make sure that those should add up to not 360 like we said it should. So 90 plus 120 plus 150 equals 360. So it works out for me. Okay? All right, question number 4. Find the measure of each unknown angle in the parallelogram below. Well, one thing you need to know about in parallelograms is opposite angles are congruent. So, first of all, we want to figure out what x is, what y is, and what c is. So we'll put that on the side so we can figure out all of these values. Well, if we have, if we know that opposite angles in a parallelogram are congruent, we know that angle z is also 118 degrees. So we can already say that this is 118 degrees. We also know that if this is y, then this is y. So we'll call this y as well. So how do I write this as an equation? Well, I can say 118 degrees plus another 118 degrees plus this y right here plus this y right here is going to equal 360 because I know the angles inside of a parallelogram always add up to 360. Well, 118 plus 118 gives me 236. So I can say 236 plus, this combines together to give me 2y equals 360. Subtract 236 from both sides, and I end up getting 2y equals 124. Divide both sides by 2, and now I know that y is going to give me 62 degrees. So y is no longer a mystery. I know it's 62 degrees. So I'm going to label y in here as 62 degrees. Last piece of information that we need to know that's going to be helpful to us is the fact that these create a straight line. And we know a straight line is 180 degrees. So to figure out what x is, I would take x plus y, and I know when I add them together it should be 180. Well, if y is 62, I would say x plus 62 equals 180. Subtract 62 from both sides, and I end up getting x equals 118 degrees. So this right here should be 118 degrees. So angle x right here I know is 118 degrees. So therefore, I've gotten all of my answers right here, and I'm okay to go for this question, okay? Now, one thing that I want to make sure that you guys understand as well is, since we have a parallelogram, this length is parallel to this length, and this line segment right here, or this ray I should call it, is our transversal. Remember our transversals that we talked about in class. And if that's the case, then we end up getting angle x and this 118 degree angle are corresponding angles. So if this is 118, then this would have to be 118. So that answer of 118 should make sense to us. Okay? Question number 5 we're going to talk about together as a class. So don't worry about number 5 for right now. We'll finish this up next time I see you guys in class. I hope you guys have a great night. Bye.